Hello Year 11, welcome to week 18 of our revision. This week we're looking at 2.5 on paper 2, which covers programming languages, compilers and IDEs. There's quite a lot of content of this session, so get ready to go. You should have your sheet ready in front of you, sheet 18, with a pen ready to complete. Okay, we're going to start off by looking at remembering programming languages. So remember, when you're writing programs to run on the computer, there are two main levels of language. There are high level and low level. High level languages are languages that have source code, the code that is easier for humans because it uses English style command words, things like print and for, while. Makes it much easier for humans to use. However, computers need to translate it into machine code, binary, before it can read it. They have to be translated. High-level language, however, can be run on many different types of computers and processors. You can write it in one language and run it on many different types. And one instruction at high level can mean many different things at machine code level, binary level. The word print, for example, could mean lots of different things when it runs it. One instruction, many at low level. However, there are also languages designed for computers rather than humans, such as machine code and assembly language. These are low-level languages. Low-level languages are easier for the computer to run because they are closer to machine code or binary, but they are much harder for humans. At low level, one instruction is one in machine code. There is a one-to-one relationship. And low-level languages are written for a specific computer or processor. They only run on one type of computer or processor. Each processor has its own different types of low-level languages. However, they are more memory efficient. Programmers can directly control how memory and RAM is used. So there are benefits as well. So remember, it's very hard to write in machine code. So machine code is the only thing that the computer can run directly. Assembly language, however, is slightly higher than machine code, and it uses short mnemonics, short keywords like add, sub, LDA, to make it easier to program for humans. Okay, so short commands, they can be used to program things like hardware, embedded devices and things, and they are easier to use than machine code. However, they still have to be translated. And every CPU, every processor has its own different version of assembly language and machine code. So why use them? Why use languages at all? The good thing is it's more memory efficient. You can directly control how memory is used. The code will run quicker because it doesn't take as long to translate it. And it allows programmers to do things at low level that might not be possible at high level. And it's good for programming things like embedded systems. You can directly control them. So there we go. There's your differences: high level and low level. On your sheet, complete this section now and answer the questions. Pause the video now. Okay, checking your answers. Let's go through the answers quickly. High level, who is it used for and why? It's easier for humans because it uses English style command words. It can run on many different types of computers or processors, and one instruction in high means many in machine code. Low level, it can only run on one specific type of processor. One instruction equals one in machine code, but it's more memory efficient and it can be used to run program directly hardware. And we've got assembly language, which is written with mnemonics, and different type for each computer system. And machine code is written in binary. And no, it doesn't need to be translated. Checking your answers now. Okay, remember we said that high-level languages need to be translated into machine code, and so does assembly language actually. So you cannot run high or assembly language directly. It has to be translated into machine code. And to do that, we have things called a translator. Translators are used to translate high-level languages and assembly language into machine code binary so it can execute the instructions. So there are actually two different types of translators that we have covered and you need to know. They are called compiler and interpreters. Compilers and interpreters. They translate high-level languages into machine code. So compilers, how do they work? Compilers translate all the source code at the same time. They take all the code and translate it and create a single executable file or exe file to run. All the code translated and produced in the exe file. Once you've translated it, you don't need to run the compiler again. It only needs to be run once to create the executable file. However, a list of errors, if there are any, are given to you at the end when it's finished compiling. All the errors returned at the end. But once the program's compiled, it will run quickly, but it can take a long time to compile it. So it would be the same as if someone translated all the code for a book, for example, and then once it's compiled, it takes a long time to translate it, but once it's compiled, you can read the book easily. Interpreter, however, is very different. Interpreter runs source code one instruction at a time. One instruction at a time. One instruction, check and run. One instruction, check and run. There is no executable file created. Doesn't create an executable file. Source is good for testing source code quickly because you can quickly test out the program without having to compile the whole thing. But you do need to run it every time you run the program. You need the interpreter. And it will stop as soon as it finds the errors. And it also runs slower because it's translating as it runs. It'd be the same as someone speaking and translating in a language, for example. They listen to one sentence, understand it, and then they're ready for the next sentence. One sentence at a time, or in this case, one instruction at a time. Okay, so there we go. Compiler, interpreter, the main differences between the two. On your sheet, I want to know what is a translator and at least 3 features for each one, interpreter and compiler. Do this now, please. Pause the video. Okay, checking your answers. Remember, translator converts source code from high level into machine code, not low level, machine code specifically. Interpreter translates and runs the code one instruction at a time, no exe file, needs to run every time you want to run the program. Compiler translates all the source code at the same time and it produces an exe executable file. All the errors are shown at the end, but once it's compiled, it will run quicker. Checking your answers and proving. And the very last thing, we've covered a lot of this topic, IDEs. Can you remember what an IDE was? So remember, when you want to write a high-level programming language such as Python, you need to use a piece of software. What is it called? It's called an IDE. So an IDE simply stands for Integrated Development Environment. It's the environment or the software that has integrated tools to help you develop programs. It's a piece of software that has tools that lets you create and program software, to write software. And one you may recognize, a Python IDE, for example, there, or Trinket, for example, is the one we use here. But there are different IDEs for every programming language, has its own one. Go. So the last thing you need to know is what are the features of an IDE? This is the example on the board on the see it for Trinket that we have used. What features does it have? Well, it's got the code editor, the main part where you write and edit the code on the left hand side. It's got line numbers and character numbers so you can keep track of where you are in the code and what you're working on. It has an output window to show the program running so you can actually see the output of the code when it's run. It has debugging tools to help you find and fix any errors, specifically syntax errors. It tells you the line number and the type of error that's occurred. And of course, you can't see it, but it has a translator that converts it from high-level languages into the output you see, machine code. And in this case, it's actually an interpreter that's using a translator. Interpreter. Okay, last thing on the sheet then, complete this section here. What is an IDE and what are the main features? Pause, complete, ready to check. Okay, checking your answers. So an IDE stands for Integrated Development Environment. They could ask you that. It's a piece of software that has tools to let you create and program software. And the features, you've got code editor, translator, output window, debugging tools, and the line and character numbers. Checking your answers on your sheet before we finish today. Okay, as always, now go to LearnCumDean, please. We are on week 18, so revision quiz 18. Check each answer, improve, correct, ready to check in lesson. See you in lesson.